So recall that a conducting wire with a current running through it will experience a magnetic force when placed in an external magnetic field. So say, for example, here's our wire. And it has a magnetic field. So I'm just going to represent that with my x's going in. That's my magnetic field. So if my conducting wire has a current running through it, let's say we're told that the current is going down like that, it will experience a magnetic force. So since this is electrons, we use our left hand, it's going down, my magnetic field is going in, so the force experienced is this way. Okay? So we've done that. So now we're going to take this one step further and say that the opposite of this is true. So this was the lesson we just did before this. That was 4.4.
Isn't FM?
Okay. A conductor forced to move through a magnetic field can induce or produce an electric current through the conductor. So if a conductor is forced to move, that can actually induce the current. So, but it's going to be in opposition, and I'll explain that here. So say we have, here's our wire this time, and say it's moving through, okay, it's moving that way. So that's its original motion. That's not its FM right now, okay? That's just like its original motion. And say, again, I have a magnetic field, okay? And what I will have, so say this conducting wire is positive at this end and negative at this end. Oh, actually, I'm not going to tell you that yet. Well, it doesn't matter. You don't have to erase it. But so what I need to think to myself, and this will come soon, is the force that needs to be exerted on it needs to be in the opposite direction of its original motion in order to induce a current. So this is the FM to oppose original motion. So now, if we did it, we have our B is going in, our FM is going this way, and so our current is going up now. So, and that's why I said here's positive and here's negative.
Why do we have to know which way velocity is going?
Because the conductor is forced to move through a magnetic field. So if it like wants to go this way, or if, because it's like you have to do work on it. So if it was originally going this direction, you have to force it in the other. I'm going to give you lots more examples. So.
The electrons go towards the negative?
Yeah, they're like flowing away from the negative into the positive. Yeah. So the electrons in the conducting wire will move to one end of the conductor, leaving one end positive and one end negative, similar kind of to a voltage source. Thus, if the conducting wire is connected to an electrical series, the electrons will flow through the electrical series and do work. Now, here's kind of about the forcing thing. The process of producing the induced voltage in a conductor by forcing the conductor to move through a magnetic field. Am I going too fast? Sorry. To move through magnetic field is known as electromagnetic induction. And this will result in an induced current. So we will use Lenz's law to predict which way the induced current will flow based on the direction of the magnetic field and the direction the conductor is forced to move. So Lenz's law states the induced current flows in the direction as to oppose the direction of the applied force.